Hello. In this short video, I want to look at graphing rational functions and finding points of intersection. So if we look here, we have two graphs, one in blue, which is the straight line y equals x plus 1, and one in red, which is 4 over x minus 2. Now we can see that straight line would have been pretty easy to graph, but we had Desmos do it for us, which is kind of nice. And again, the rational function wouldn't be too hard. We can see there's going to be a vertical asymptote here at 0. There's a horizontal asymptote here at y equals 2. But what we want to do is find these 2 points of intersection in green. And unfortunately, because we turned off the grid, we can't see exactly what they are. But we could use algebra to find the values. So what we do is we set them equal to each other, because algebraically that's what it means to have a point of intersection. It means the 2 functions are equal. And now we go about the process of solving. I think one thing we could do would be to move the 2 to the other side. So we could add the 2 to both sides. That'll be 4 over x equals x plus 3. Now we're going to multiply the x to each term so we can get rid of that fraction. That'll be 4 equals x squared plus 3x. Let's toss that 4 to the other side so we can have our quadratic. We'll factor down our quadratic as x plus 3 and x minus 1. Oh, that's not quite going to work. Maybe 2 numbers and multiply to give 4. Oh, x plus 4. There we go. X plus 4, x minus 1. That looks good. So x equals negative 4 and x equals 1. So those are the 2 x values. So this point over here would be at 1 and something. And this is 4 and something. So if we're asked for the solutions, we just put the x values. If we're asked for the actual points, we have to now plug these in and get y values. So here y would equal negative 4 plus 1 would be negative 3. So negative 4, negative 3. Here y would equal 1 plus 1, so y would equal 2. All right, so those are our 2 points of intersection. So I would like you to go ahead and pause the video and give this one a try. I'm not going to give you the graph to start. I'm just going to ask you to do the algebra, set them equal, solve them, see what you get. And then we're going to compare with the Desmos, and we'll look and see how our algebra matches up with the graph. All right, assuming you gave this a try, we should have x over x minus 2 plus 1 over x minus 4 equals 2 over, well, let's just factor this. This is going to be x minus 4, x minus 2. Now what that means is if we want to clear the fraction from all of these, we could think of making them all the same. So this one here is going to need an x minus 4. This one is going to need an x minus 2. So we would have x squared minus 4x. We would have x minus 2. And we'd have 2. Now these are all going to be over x minus 2, x minus 4. This is x minus 2, x minus 4. And this is x minus 2, x minus 4. So since the denominators are all the same on all the fractions, we can simply cross them out. This gives us x squared minus 4x plus x minus 2 equals 2. All right, we have got a quadratic going on, so let's collect all the terms on the one side. X squared minus 3x minus 4. That's going to factor down as x minus 4, x plus 1. So x equals 4, x equals negative 1. Okay, so those would be our 2 solutions. And let's go ahead and look at the Desmos version of these 2 equations. All right, so here we see the 2 graphs. They're both kind of interesting radical graphs. And the one in red has a couple swooshes with this kind of S curve in the middle. The one in blue has like a U curve in the middle and then a couple swooshes up top. And when we overlay them, we have this type of setup. And if we look, we definitely have a point of intersection over there at x equals negative 1, and we found that with the algebra. But if we look at x equals 4, I don't see anything. Over at 4 right here, well, if I look down, there's no intersection. And that was weird because we thought x was supposed to equal 4. I mean, the one over here is good. X equals -1. I see that point of intersection. But there's nothing at the 4. And then if we think back to our question, we might say, oh yeah, x cannot equal to 4. And then over here, x cannot equal to 2. So what that means here is that the x equals 4, we have to reject it. We have to reject it. It is an extraneous or false solution. The x equal to -1. Oh, sorry here. Let me just. The x equal to -1, that passed. That was accepted because that didn't have any problems with our NPVs. But the x equals 4 was exactly one of the NPVs. So it has to be rejected. Now, I mean, it's possible that we have a different NPV as well from here, but when we factor this, we got x minus 4 and x minus 2. So these were the same NPVs as the first. So overall, the NPVs we have are 4 and 2, nothing additional to that. And so when we're solving the algebra, if we end up with a 2 or a 4, we have to reject it. Any other number, we're good to go and we can accept it. So let's go ahead and take some quick notes on this. We would say we are solving rational equations. Again, this is a bit of a crossover from grade 11 because in grade 11 you definitely worked on these and you solved some rational equations. But now we're looking at the graph and we're kind of comparing the graph, the algebra, and we're just kind of taking it to that next level. So the basic idea here is you would graph the functions. You find points of intersection. And you have to reject any points that are NPVs. So if you want a real challenge here, I'll give you y equals 1 over x squared plus 1 and y equals x to the 3 minus x squared over x to the 3 minus x squared plus x minus 1. This is a real challenge. You got to find the points of intersection on these two rational graphs. And again, you don't necessarily have to graph the functions right away. You could do the algebra first. Sometimes on these questions, it's sort of maybe like a part A, part B. But for this one, I'm just going to encourage you, skip the graph and just solve it. And then I will pop up the graph and we'll compare your work to the graph. All right, so assuming you give that a try, we want to do the factoring here. So this is x squared, x minus 1. In the bottom, if you use synthetic, you should get x minus 1, x squared plus 1. So those will cancel. Now we can set these equal to each other. So 1 over x squared plus 1 equals x squared over x squared plus 1. They have the same denominator, so you can cancel that out. That's going to give you 1 equals x squared. So 0 equals x squared minus 1. 0 equals x minus 1, x plus 1. And so x equals 1, x equals -1. Now, we do have to keep in mind that because we had this up here, we have an NPV. We would state that x is not allowed to be 1. And so over here, this has to be rejected. But this one can be accepted. Real quick, let's take a look at the Desmos. So these are both some pretty interesting graphs. And if you look at them on Desmos, it highlights that there's a point of intersection right here at -1. But while it might look like there's a point of intersection over here, nothing gets highlighted. And that's because on the blue graph, where it looks like they're about to intersect, there's actually a hole on that blue graph. And so the two graphs pass right between each other and do not intersect because x equals 1 ends up being a hole on that blue graph. Now for some extra practice, you can try worksheet number 10 and 10.5. And you can write down any things to remember. Again, the best thing that I find is if you have some type of fraction over some stuff equal to another fraction over some stuff. As long as you have the same stuff under all the fractions, you can just cross out all the stuff, and now you have a nice equation that doesn't have any fractions. I find that to be a nice technique, and it helps when you're solving these rational equations. All right, hopefully you enjoyed this video, and as always, thanks for watching.